All right. Good afternoon, everyone. Welcome to this next edition of the National Corrugated Steel Pipe Association's Real Deal on Steel webinar series. I'd like to thank you all again for attending this seventh and final session of our seven-part series. I'm Mike McGough, Executive Director of the National Corrugated Steel Pipe Association, NCSPA. And as usual, I will be moderating the webinar this afternoon. Again, we have a chat box on the side there, so please feel free to enter any questions or comments as we walk through our presentation today. We will try to answer them in real time if we can. So, for today's topic, we are going to be covering rehabilitation practices and solutions for using corrugated steel pipe, CSP, and structural plate. We'd like to recognize our sponsors for this particular series. They're being brought to you by, of course, the National Corrugated Steel Pipe Association, NCSPA, in partnership with our friends at the American Galvanizers Association. As I said, this is the seventh and final installment of this particular webinar series. I want to thank you all again for joining us on this journey. I know that many of you have been with us since the beginning and throughout the duration. We certainly appreciate that commitment. Now, just to give a quick recap of the previous topics that we've covered so far. If you recall at the beginning, we started with the standard coatings available for CSP. We moved into the structural design methodologies, both the AISI method and the LRFD method for structural design. We covered in very good detail the installation practices used for corrugated steel pipe and structural plate. We then moved into detention, retention, and water quality system installation, design, inspection, and maintenance. We had a very good session with our friends from Canada on sustainability. Our most recent session a couple weeks ago, we covered quality, traceability, and certification programs. And now we are going to bookend it here with rehabilitation. If you were unable to attend any of these sessions, or if you want to hear them again for future information, further information, if you want to look at some of the slides or download them for your own review, they can all be found on the NCSPA website. So feel free to look at those and use those as you wish. Also, just a quick reminder that PDHs are available for those participating this afternoon. So please be sure to complete your information at the end and take advantage of this free survey or free opportunity. So once they're uploaded to the NCSPA site, the PDHs no longer become available. They are simply only available for those attending the live version. So, membership of the NCSPA is comprised primarily of steel coil manufacturers, coaters, and fabricators. The mills or manufacturers will produce and coat the steel sheet coil and then ship it to the various fabricating companies that will in turn roll form, rivet, or fabricate the steel into the various profiles for either pipe arches, or structural plate buried bridges that have been installed under our nation's highway system for over a century. Today, we have two co-hosts for our webinar. On the second half of the presentation, we will have with us Jerry Salagi. Jerry's Chief Engineer with Lane Enterprises. Jerry was educated at the University of Illinois. He holds a Bachelor of Science degree in Civil and Structural Engineering. He comes to us with 14 years of municipal experience, as well as 13 years of experience with Lane. Jerry is also the newly elected current president of the National Corrugated Steel Pipe Association. So again, he will be talking to us in the second half. But taking over for me now, here in a minute, is helping us bookend all of this is Scott Hensley. Scott's with member company True North Steel out of Fargo, North Dakota. Once again, he's a Razorback from the University of Arkansas with a Bachelor of Science degree in petroleum geology. Scott has over 30 years of extensive experience with corrugated steel drainage and buried steel structures. With that, Scott, take it away.
Thank you, Mike, and good afternoon from sunny Colorado. The next few slides that I'm going to speak to really are more general in nature, and they focus upon site conditions and structure conditions that could lead us to certain methods of rehabilitating culverts and bridges. Not necessarily endorsing or any of the use of any of these, but the point is really simply to really make sure you understand proper applications for some of these methods, because there is a fair amount of confusion sometimes when it comes to evaluating the existing structure and then leading to the right way or the best way, most economical way, maybe to rehabilitate these structures. And sometimes what we're dealing with is a great solution for corrugated metal pipe. Sometimes there are simpler solutions, and I wanted to show you some of those, but as Jerry gets into the presentation here, he'll drill in on specific applications for the use of different forms of corrugated metal structures to rehabilitate, like I said, culverts and bridges. So these are just a couple of photographs of different applications, for some materials that we'll talk about briefly in a minute, and then slip lining with corrugated metal pipe. We've all seen these reports come out, over and over and over again that really speak to the number of bridges that are rated structurally deficient in the U.S., and that number keeps growing. We're more dealing with culverts, but I want you to keep this number in mind, this 612,000 bridges rated structurally deficient, and then look at this presentation from SG&H from, I think, 2018, yeah. And the culverts outnumber bridges significantly by about 10 to 1. So if we had 612,000 bridges rated structurally deficient, think about how many culverts are out there that are in need of being repaired. And there are no really, any federal mandates as there are for bridges for inspecting these structures. And really the point here is we have to do our best to try and inspect these culverts more routinely so that we can catch them, at a situation or a point in their life when we can rehabilitate them, not wait so long that, they literally may have to be replaced. So just wanted to mention to you this manual. Mike, I said you didn't think that this was finished or sent out, the newest version of this, is that correct? I'm going to force Mike to get back on sound. I don't know if he can get back on now, but we're waiting for this updated version of this FHWA document on culvert inspection to be released, and hopefully that'll be soon. So a couple of things to keep in mind as we talk about all these, hundreds of thousands of culverts out there. Many of these culverts have been in the ground 50, 60 plus years. If you think about the construction of the National Highway System in the 1950s, how many culverts, just under that one roadway system, and how old those structures are. They're reaching close to 70 years, in the ground. And one question I always like to point out to people is, what was the specified design like for a culvert under the highway system and the National Interstate Highway System constructed in the 1950s? And to kind of cut to the chase, I believe it was either 20 or 25 years design life. And they've been in the ground for 70 years. So it just points out, the situation, that we're dealing with. Certainly, all public agencies, they're trying to stretch their budgets when they're maintaining structures in their municipalities and areas. and looking for ways to stretch those budgets. And one of those ways is to rehabilitate culverts and small bridges. And that's what we're going to obviously drill in on today. So, we're facing, rehabilitation of a structure versus, physically replacing it. And there are a lot of factors that, for sure that go into making that decision. And we'll talk about some of those, but usually, in what we'll call a typical average culvert application, rehabilitation can be half the cost of removal and replace. Certainly, if it's shallow cover over a culvert, then that could possibly lead to a situation where replacement might be the way to go. And as the size of the culvert or diameter and the burial depth goes up, then it leads you back towards rehabilitation. And in our book, rehabilitation means extending the service life of that existing structure, until we can get it back to whatever the requirement is, to a 50, 75-year extension of that design life. That's the goal, and it can be accomplished in many cases. So rehabilitation versus replacement, another factor is permitting cost, road closure time, all those things go into the math when you're trying to decide whether to rehabilitate or replace. So every situation is unique. That's a given. Everybody understands that. Some of the structures that we're going to talk about today on rehabilitation are small bridges. Some of these bridges you'll see that we're rehabilitating aren't so small, but also concrete boxes or even concrete pipe and corrugated metal pipe, structural plate or steel structural plate, and there are obviously other applications, but these are the three that we're going to show you examples of today and really dig in on. So some of the challenges and things that we have to consider when we're thinking about rehabilitating are, what is it that's causing the distress of this structure that we're considering taking this step. Certainly structural deficiencies, cracks, all kinds of things that could lead to a structural deficiency, including backfill problems. Can't tell you in the last 30 years how many times we're looking at replacing these structures, not because the structure itself is experiencing problems. It was maybe more a problem of the original installation that's really manifesting itself over time and has reached a critical point. Leaking joints, in the pipes or culverts, cracks, corrosion, perforations, certainly deflection. And that last one is a tricky one. And one of our last slides really suggests, that you reach out to experts like Jerry, Mike, and myself, and others who have seen a lot of things, and especially when it comes to deflected structures, because understanding what's acceptable, in terms of the level of deflection and what is not, it is something that, like I said, can be fairly tricky. So designing of slip lining systems, Jerry's going to really speak in detail to slip lining structures using corrugated metal pipe, but usually when we approach a slip lining application, meaning inserting a new pipe inside of an existing structure, our goal is to design that as if that old structure is no longer carrying the load. That new structure should be designed to carry the full live and dead load as if that existing structure were not there. That's the typical approach. Certainly in that case, we have to understand the condition of the soil backfill or foundations. And certainly if there have been perforations in the pipe or cracks, are we experiencing backfill soil loss? And that happens quite often. once that happens, there are other steps that have to be taken, obviously, to successfully rehabilitate the structure. And then another or another piece of this puzzle is, if we're slip lining, we could be inducing, a reduction in hydraulic capacity that has to be considered. Now, there are ways to do that, especially if you're rehabilitating something like a corrugated metal pipe structure. There are ways to do that with smooth interior pipes that, in certain cases, can actually increase the hydraulic capacity. We'll talk about that later. So again, structure types we're going to address today. Rehabilitation using corrugated metal pipe. We'll show you some examples. Stone and concrete structure slip lining. The repair of the invert of corrugated metal pipes. There are thousands and thousands of corrugated metal pipes out there that are 50, 60 years old. The structure's in great condition, and all we have is an invert that we need to repair. So we'll show you some ways to do that. And then slip lining, just straight out using corrugated metal pipe to slip line existing structures. So in looking at these solutions that we're going to review here in the next couple of slides, I've really broken down into structural repairs and non-structural or kind of semi-structural repairs. It kind of depends on the application, but the structural repairs, certainly slip lining with corrugated metal pipe. See a lot of applications where existing structures are slip lined with solid wall steel pipe. This one I'll skip over. I'll show you an example of that later, but slip lining with plastic pipe, that's often done with solid wall HDPE pipe. And I'll show you some examples of shotcrete steel mesh that is often used to repair culverts. On the non-structural side that we'll look at, certainly, in my example of that 50-year-old corrugated metal pipe, the invert was all that needed to be repaired. That's not necessarily a structural repair. We're seeing a lot of new products coming online that are spray-on urethanes and other epoxy coatings. Those are a non-structural repair. Separate from that would be cured and place liners, and I'll show you exactly what I'm talking about that here in a moment. But these are one of those that could fall potentially into the semi-structural repair category. I mentioned spray-on epoxies, spray-on fiber reinforced plastics, fiberglass is something fairly recent. And I'll show you another recent development. It's generally called a concrete cloth. It's a geotextile that's impregnated with cement. And I'll show you an example of that. So the structural fixes, obviously this is a structural fix. We're slip lining an existing structure with a new corrugated metal pipe that's designed, like I said, to carry the full live and dead load that the existing structure once carried. And Jerry will dig in on how this is done, some examples of how it's done, but it's just what it looks like. It's inserting segments of corrugated metal pipe, connecting those pipes, and basically rehabilitating that structure as if turned into a new corrugated metal pipe. I mentioned different ways of slip lining structures. This is again a structural fix using plastic pipe. There are different types of materials out there that are widely used, everything from simple off-the-shelf solid wall HDPE pipe that's slip lined in and fusion welded. There are profile wall HDPE pipes. There are solid wall HDPE pipes with kind of proprietary connections that connect one piece to another. And in certain cases, these are certainly a viable repair for structures. One of the things that we've seen in the last 10 or 15 years is the use more of solid steel. These are typically weathering steel structures that are shaped to fit existing structures, kind of different shapes, like this is a pipe arch. Certainly plain off-the-shelf solid steel, black steel pipe is used commonly on smaller diameters. You see a lot of that on railroads, slip lining existing culverts. Absolutely a viable solution. And in both of these cases, this one and the previous, typically the annulus or the void between the existing and new structure is grouted. Same with this one. And one of the last truly structural fixes is where contractor goes in and places steel mesh, and then actually applies a shotcrete to it, and then it's troweled to a smooth finish. To truly look at this, there are more factors that would lead you to one of these solutions, including cost. Some of these are excellent solutions and they're viable, but they're unbelievably expensive and get to the point where it's almost a better way to go to just replace it. There are certainly times when this is a good fix, for instance, but it's really expensive compared to, say, slip lining. Now talking about some of the non-structural repairs, I mentioned those 50 to 60-year-old corrugated metal pipe structures that are out there. This is a perfect example of one it's probably been in the ground 30, 40, 50 years, and this entire perimeter is in perfect condition, but maybe due to abrasion from abrasive bed load or highly acidic flows, the invert may need to be repaired. And this concrete invert is a very economical, fast way to rejuvenate a structure like this and give it another 75 years of design life. And this is a cross section of what that would look like. Rebar, or typically more mesh, is tack welded or tied to studs in the bottom, and then concrete paving is applied to the interior of that structure. And frankly, there are some situations where that is applied the minute a new structure is installed, just because we know we're on a steep grade and we know we're going to have large rocks rolling through the bottom of it. Sometimes this is done, like I said, immediately after the initial construction. Other non-structural solutions, joints leaking. This looks like the contractor is going in and injected a foam material to keep the water from coming in. I will say, if anybody's ever gone into their basement and tried to keep water from coming in through a crack, trying to fill that joint is difficult. So it's not an easy thing to do, but it can be done. I mentioned some of the spray-on coatings, and just a cautionary note to these: they are absolutely non-structural fixes, and I'm sure there are good applications for them. Honestly, what we're looking at here is that's not really a great application for a coating like this. It's a very thin coating, similar to what you would see in the back of a pickup truck, and it can certainly protect, in this case, steel or whatever from corrosive water situations, but it's definitely not a structural fix. And if you look at that application on the right, that is a place where we simply needed to concrete pave the invert. Instead, we're spraying the entire 360-degree perimeter of this thing for really not a good reason. But certainly there are places where this would be appropriate. And cured in place liners, if you're not familiar with this, these have been out quite some time, typically used to repair sanitary drains, storm drains, where a different type of liner or a material is laid into the pipe and then filled typically with hot water that cures this material into place and creates a pretty darn thick layer on the inside. So those certainly add some structural component to the fix. Again, kind of like shotcrete, they're very expensive, but again, it's finding the right solution for the problem. And this is a widely used solution. Mentioned earlier, the cementatious fabric. We're seeing some situations where this is being tried out, and it hasn't been used that much. In theory, if it's properly anchored to the invert, it could be a solution. As compared to that concrete paved invert detail we looked at a little bit earlier. I would say the jury's still out on this, and we'll continue to watch it and see if it holds up and turns into a good, reliable, long-term solution. So with all these options, and that was really just a quick snippet of some of the solutions that are out there. There are more, and you're looking at another one there. This is a spirally wound product that the pipe is actually made into pipe as it goes into the existing structure. But how do we decide what the best way to approach this is? And there are many good references out there. I showed you that one document earlier from FHWA, that in the 1986 version that's in the process of being updated. Caltrans has produced an excellent document, and as you can see, they call it a supplement to that same culvert repair manual. And if you want a copy of this, we can get it to you, or you can get it off the internet pretty easily. But it's a great document, very comprehensive. One here produced, I guess it's technically by the USDA Forest Service. Good document. It's a little bit dated, but got some good examples in it. Many DOTs have produced great culvert rehabilitation guidance documents out there, and they've all kind of got nuggets in them that are very helpful. Another good document here specific to larger corrugated metal pipe structures and repair, and how to survey them and evaluate them. A good document. But really, what they're all taking you down decision trees to consider the reduction in hydraulic capacity. Sometimes that's a problem, but if we use the right materials with a low enough N factor value, we can actually, in some cases, increase the flow capacity depending on the condition of the existing host structure. And certainly, we have to think about live and dead loads that the structure is going to feel. We would want to go out, and especially if we're looking at an older structure and we're seeing signs of corrosion and abrasion, it would be appropriate to go out and do some inexpensive chemistry checks on the flow and the soil. Some of the other considerations are construction access. Sometimes these culverts, you just don't have good access, to slip line or do a certain type of construction process. So that can weigh into the decision. Dewatering, the need to dewater, sometimes that's more critical with different types of rehabilitation methods than others. And then that condition of the existing structure. Sometimes they can be a little bit rehabilitated. Sometimes it's best just to walk away and replace it. And until you've seen a lot of these, sometimes it's not clear what to do. And again, I mentioned earlier, deflections in existing structures. Sometimes it's best to call somebody who's seen a lot of these. There are certainly third-party engineers with a lot of experience that we can point you to, if that's what you prefer. And like I said, I can't tell you how many times, a poor original construction practice, whether it be lack of compaction or poor backfill material, just over time, manifests itself and eventually gets to the point where, it's leading to excessive deflection, for instance. And then, you've got a separate problem because you really can't often fix that backfill deficiency. So, again, drilling in further on what those guidelines I just showed you, kind of the thought process they take you through. Careful examination of those existing site conditions, obviously, visual condition of the soil backfill. Sometimes we can utilize some tools and from the inside of the structure, evaluate the condition of the soil backfill. When did the damage occur or deterioration occur? Sometimes it's gradual over time. Sometimes that damage actually occurred 40 years ago when the structure was installed and it's just showed up now. So it helps to be able to look at a structure and understand when it occurred. Because if it's 40, 50 years old and there's some minor deflection in there, you may not want to mess with it. Measure and evaluate any deflections. There unfortunately are not a lot of published great guidelines out there for what's acceptable deflection. It's more an experience thing. Sometimes we can take core samples of the wall, get some idea of what the condition of the soil is. Like I said, taking the pH and resistivities and measure for sulfates, and then understanding abrasive flow. Again, all these things are going to point you to different solutions. So with that, now that you've kind of got a broad look at what is out there, I'm going to turn this over to Jerry Salagi, and he is going to really drill in on slip lining with corrugated metal pipe and structural plate. So, Jerry, you're on.
Oh, thanks, Scott. Good afternoon, everybody. At this point in the program, it's sort of presumed you're going to move forward with slip lining using a corrugated steel pipe or structural plate for your reline material. And one of the things I'd like to impress upon you is that there's really, no one way of doing this. Even on one particular project, there's a number of different approaches to achieving your objective. Every rehab is unique. What I do want to do is go over some of the considerations that help you narrow in on the specification or the construction sequence or what you might be looking for by way of submittals from the contractor. And today's presentation, for the most part, is just reinforcing a lot of the information taken up in the chapter 12 in the corrugated steel pipe design manual. And I will touch on a little bit on some hydrostatic buckling that might be involved with your project. That particular topic is taken up in chapter 8 of the design manual, Structural Design for Special Applications. So once a liner is specified, there are only really two items to address. And, how does the liner get into the place and how is it secured? And a lot of this can be taken up in your specifications, either specifically or generally. I suggest getting the contractor involved as far as determining the means and methods. Probably something you might request as being part of the submittal process, and any final determinations onto who gets the job, you might base some of that decision on. Just a few slides here. Just, photos really do say 1,000 words, and I want to start off here with a few slides on structural plate. A little bit unique if you're not familiar with the product. These are just curved plates that are field bolted. And you can see here they're assembled in segments. One of the main differences here, there's no joints. So these are all lap seams, and it's one continuous liner. This here shows the placement on somewhat of an approach into the tunnel lining, and that excavator is really just going to swing that or pull it into position. What makes this one a little bit unique is that particular arch structure is pretty heavy, and it's sliding right on top of a concrete pedestal. And I got a video on this. It makes an awful sound. That's a lot of weight. So at 180 pounds per foot, we're looking at when they're sliding in the final piece, they're trying to move almost 30,000 pounds of reline material. And I believe at some point they were actually pulling this from the other end while they're performing this action at this end. But I would consider this kind of a worst case. It was still achievable, but there are options to lessen the friction or the resistance to sliding on the material they were trying to slide on top of. There's plastic strips and so forth that could be used. Another structural plate where we're illustrating pulling. Again, these are being assembled on the one side, and then they're pulled until they get to a point where they want to attach another segment. And here they're just using some brackets that were placed around the periphery of the pipe arch. And if you look at the photo closely, you can see that the rise is being somewhat shortened by those turnbuckles there. And I think, you know, when they let those loose, there's going to be a tight annulus around that pipe. And that might present some grouting challenges we can talk about a little bit later on. But the photo on the left shows this is actually being slid on what looks to be some flat stock, some steel, and to lessen the coefficient of friction there, and just to make the job a whole lot easier. It's a big consideration. How is that going to slide effectively? And like I say, contractors will vary in how they decide to do that, but they all seem to be pretty unique in their approaches. Third slide here, another plate one. This is one of the advantages of structural plate. It can be assembled in place. It took this crew here one day to assemble that structure, which is a little bit over 100 feet long. And just as a note, you'll see some of those alignment bolts around the periphery of the structure, putting it into place. And we'll talk about the alignment bolts in a few slides. But go over an example of corrugated metal pipe as our pushing illustration. You can see on the right photo there, a couple pipes being used as rails to slide the reline material in on. And those guys really aren't pushing the pipe, although it looks like it, but it's not that difficult to move this kind of a reline material on that setup there. So liner placement, next we want to talk about liner securement. And one of the first things we do is get that pipe or the reline material exactly where you want it. And, you know, and alignment bolts are how we position that to meet the alignment on your plans. What makes this particular photo a little bit interesting is that's actually a fitting. And so that's a bend. And the next piece is going to have to be pushed from the other end to join that. But you can see those are pretty stout alignment bolts. Out of all the photos I've had, those are the biggest bars I've ever seen. But I don't want to confuse anyone. They're not to hold the pipe in place during the grouting process. That's not what they're for. That's going to be achieved a little bit better by a setup like this, which is just a series of floor jacks and going through a 2-inch grout port at the 12 o'clock position, regularly spaced. I got a couple photos here. One showing continuous timber or continuous support along the bottom of the reline pipe, and the periodic spacing braced up against the host pipe. This is a strongly recommended detail. It just makes things so much easier. Here's an example of a grouting process. Now that we've held the pipe into place, and we're going to pump grout in there. And I'm going to start off a sequence of slides here without grout ports. And you can see the schematic here has a series of pipes which they're going to pump grout through to get it from one end to the other. And you need something that flows really well to do this. This looks like a cellular grout. I'm going to touch a little bit about that in a few slides here. But primarily for long distances or maybe the smaller shapes that you're not going to be working inside so much as you do like the larger ones, might call for a setup like this to get that thing grouted in place. And for the larger sizes, you know, the periodically or spaced grout ports, you can see here, this varies every job. So basically, shop drawings are going to include spaced at a certain position around the clock every 5 or 10 feet. You can see in that center photo there, that's just a cap. Once you're done grouting, that cap goes on there, and then you go up and you continue the grouting progress. Those grout ports are excellent observation points to make sure as you're pumping grout in there, you can see the elevation is coming up around the periphery. And then the larger photo there, you know, just shows, if you can look closely, all those grout ports and how they're spaced. Again, that varies depending upon the application or the project or the engineer or contractor. Touch briefly on end finishes, in that it's important to, you know, give the contractor an idea what it should look like when you're done, so he'll know how to prepare for that and finish his grouting process. And I just have a couple examples here. It's just a normal type of timber bulkhead that was constructed on this structure to give it the appearance we have on the right. Contractors on this particular reline job, they just brick and mortared the ends. And then this one was a little bit different. They actually tied anchors into the embankment for this particular head wall. So moving on to some of the grouting considerations. Flowable fill, and what is it? It's basically just a really watered down concrete mix with no stone. So sand is the aggregate. Again, it's going to be heavier because it has sand in it. It probably lends itself more to the large diameter applications because you're using grout ports and you don't have to pump at great distances. You can see it's a low strength material. It's definitely, by definition, is less than 1200 PSI compressive strength. There are different mixes available and options to economize your grouting. And I think a lot of things that engineers are concerned about is what kind of strength does it need to have. And that's, you know, surprisingly, it doesn't need a lot of strength. What I have here is 40 to 80 PSI. Compressive strength, it doesn't seem like much, but it's a lot stronger than really good crushed stone embedment. And we do look at flotation when we're using this, and I usually assume about 130 pounds per cubic foot for the analysis, which means you really do have to put this in lifts. And a good way to do that is just to look at the resistance you have, the buoyancy, and probably put an equal amount of the flowable fill up to that elevation. And then that can serve as somewhat of an anchor for you moving forward. If you have some alignment bolts, that's fine, but you'll get some adhesion on your reline material anyway. And initial set for a flowable fill is, 3 to 4 hours. So if you're really pouring at a slow rate or a controlled rate, that's really going to offset the fluid characteristics of the flowable fill and the tendency to float. Let's see. Cellular grout actually is a safer way to go about doing this, a more conservative way, and it's because the densities are just so much lower. Lower hydrostatic loads. Basically, and there's no sand in it weighing it down. They're going to inject foam in it. Usually at the site, there is somewhat of a learning curve to get the grout the way to meet spec on site. An experienced contractor solves all problems. It enhances flowability. You're going to have longer travel lengths, and which you might need for smaller diameter relines or relines with no grout ports. And we can take a look at here to offset any concerns of strength that you might have. Usually, a good crushed stone backfill will give you around 4,000 psi modulus. And if you correlate some of the compressive strengths to this cellular grout in the table to modulus, you can see it's just so many times greater than 4,000 psi. So strength is really not a concern when we're grouting. We want something that flows easily and is not going to slow your project down or cause any problems. Grouting pressure seems to be something that worked its way into every reline spec, and typically what I see is something around 5 psi. And I guess what I was trying to accomplish with this slide is to try to give us some kind of a basis why that's the case. Obviously, you'll need more pressure for longer travel lengths or smaller annular spaces. But this calculation on the right is not applicable to a reline. This is more of a caisson or a vertical shaft scenario that's being filled in with a flowable fill because of the uniform pressure here. We calculate a critical buckling load with a factor of safety and say that comes out to around 9 psi. And then using here a method taking from American Concrete Institute ACI code 347, which is a guide to form work for concrete. They give somewhat of a method there with a number of variables to determine as you're filling up like a column, for instance, as it gets up in elevation. We normally, take the weight of that times its height and to put a particular pressure at a particular elevation. But when you're pumping at controlled rates, that's ultra conservative. So they provide methods here for kind of estimating what kind of pressure we're actually calling for in those situations here. And I guess the example I have here shows around 6 psi. And so probably just a great illustration why 5 psi kind of makes sense. I also took advantage of a blank spot on the slide here to show you a schematic of an internal seal. So grouting, flowable fills, you want to make sure on corrugated steel pipe that these joints are just well sealed and it will leak out. And so this is the detail that is commonly used. You can use it with a gasket. You can use it with caulk. Just the main point is to get that sealed so we're really not leaking into the structure. Here's an example of some calculations that we do to see what kind of buoyant forces we can expect. Really the first pour is the real number to look at. The second pour, the third pour in this example, they're really being offset by the weight we're adding in pour number 1. But I did a comparison here with a flowable fill at 130 pounds per cubic feet versus a cellular grout at 40 pounds per cubic feet. And you can see for the flowable fill that uplift force or the buoyant force is 2,400 pounds per foot. So great illustration of why we do pours and lifts and why we like that detail earlier with the floor jacks going through the reline pipe to brace itself on the host pipe. That same analysis here for the cellular grout shows an uplift force of around 740 pounds per foot. Big difference. Again, this example was for a 108-inch diameter 10-gauge 5x1, which provides its own resistance at around 180 pounds per foot due to its weight. And just some of the considerations that you want to look at to make sure you're specifying something safe, or when you're reviewing a contractor's construction sequence, it's kind of making sense what he's proposing to do. And again, another opportunity just for another photo here of an internal band that seals off the inside from the grouting process, an actual photo in this case. A lot of questions on, are we actually putting a grout in there that causes a corrosion potential to the steel? And what I've put here is a report from AK Steel that we sometimes use in the industry to offset any concerns. And you can see the report is done for an aluminized steel pipe. The aluminum coating is a 1 ounce per square foot coating. That's the coil or the sheet coating weight. So it's actually half of that on the one side. It's not terribly thick. And what they find is while the aluminum, while the grouting is curing, it does attack the aluminum, but it hits this interface, an alloy interface, and because of the iron content, which is, enhanced, the corrosion behavior of the steel is actually enhanced by alkalinity, it just stops there. That alloy layer between the aluminum coating and the steel substrate is pretty durable, it's pretty hard, and certainly offsets any concerns of any corrosion. And here is the last bullet item. We are researching, but we do cite a report by Caltrans that they do look at the solid aluminum pipes and what kind of effect the alkalinity is having. And the conclusion is it does go through the aluminum a very small amount until the concrete's cured, it stops. If that bothers anyone, and at times it does, specifications include for putting a paint coating on the outside of the reline material, which is a complete barrier to any kind of corrosion. There's nothing special about the paint. Get involved with several of the DOT specifications, and the types of paint they cite would leave one to believe that there is a magical paint out there, but I would just go to Sherwin-Williams and buy a cheap primer myself. That backing up to the previous slide really quick, I should probably note there that is page 1 of that report. There's a second page that includes a lot of information, photos, measurements, just data of sorts. And of course, that's available at ncspa.org, or anyone in the industry could provide you this report. And touch on a couple structural concerns you may have. I think we can completely offset those. Basically, liners or reline materials, corrugated metal pipe and plate are supposed to be designed as a standalone structure. And unfortunately, they are. I say unfortunately because they're virtually feeling no stress in this application. And you can look at the diagram on the left. This is an image taken from the solution methods and formulations from the Candy software and the information that comes with that when you download it, which is available for anyone for free at candyforculverts.com. And so I guess intuitively that host structure was holding everything up before we came along with a liner pipe. And so by the time you put a liner pipe in there and inject the annulus with grout, it should feel no transfer of any load at all. This bears itself out in a number of presentations and finite element analyses. I think I've been subject to a lot of presentations over the years, and this seems to be the conclusion always reached when this is modeled, and it sort of just makes sense. I guess a good reason to bring this up is not just economy as far as getting a thinner material, but thinner materials are easier to work with. You'll have less problems and you'll have better outcomes. And, just getting through any project, as we can all attest, is an achievement. Well, we really want to mitigate any problems, and any problems we can foresee. It certainly does. It is empowering to have the ability to notch it down as far as what we're proposing and not go overboard. Another structural slide I have here, basically, I think Scott touched earlier on the culvert paving, a concrete pavement on the invert. Since at the flow line or below the flow line, abrasion usually removes coatings over time, exposes the steel substrate to chemical corrosion. And that's why we're seeing in some instances where abrasion is a factor, that those culverts are really only damaged at that flow line elevation and below. This here on the right is a 2-page summary of what is actually a 446-page report entitled Structural Benefit of Concrete Paving of Steel Culvert Inlets. So basically, all these DOTs you see listed on their slides, or virtually all DOTs, period, have a detail similar to this, that they would repair an invert with this concrete pavement, this concrete lining with the rebar and the mesh and all that. This particular report went through these DOTs, these 10 DOTs, and their details. This report was filled with computer simulations, which showed repeatedly that invert repair restores the culvert structurally. So I think earlier we mentioned that that was a non-structural repair. This is a June 2017 report that concluded this is a structural repair, and the structural capacity of that pipe is completely renewed. That was done with, of course, a lot of finite element analysis and some field load tests. And there's a load frame facility at the University of Ohio, I believe, and that concluded all the same. So that's a good repair. It's used a lot. We love to sell you more pipe, slip line projects, and so forth. This is just something that shouldn't be overlooked. It kind of plays itself in to a life cycle cost. Why are we concerned about life cycle? It seems like we're the only industry talking about it, because engineers should be cost averse. Service life is a consideration, and it's good for business, our business anyway. But these tools are available. That ASTM standard is available, and they were originally developed for remove and replace. And I put this slide here today because I think we've just ratcheted up the benefits of using steel pipe by proposing a concrete paved rehab or a slip line to extend service life. With all the culvert inspections going on today, the asset management programs, these things are getting looked at. We anticipate seeing more of these. And I think the slip line and the culvert concrete pavement are going to be the two most valuable methods at going after a lot of this work. And Mike, that is all I have for today, and I'll give it back to you.
Thank you, Jerry. Thank you, Scott. Really great information, guys. A lot of great resources that you included. Really appreciate it. So I know we're butting up against the end of our time here, gang, and trying to respect everybody who's attending. I'm going to cruise through these last few slides a little bit in the essence of time, but just to kind of recap where you can get more information on what we're talking about. Of course, the NCSPA website, ncspa.org, is a really great resource. We recently launched a new website, new feel, new look. We are also in the process of building out a bunch of different aspects to this site, including rehabilitation, including installation, including sustainability, and the like. So, keep checking back for information there as we continue to post. Of course, we have a lot of great projects listed on the site. Those must have been some old slides. We have a lot of great projects listed on the site that we'll get into here in a minute. Jerry mentioned the Corrugated Steel Pipe Design Manual. Chapter 12 covers rehabilitation, maintenance, and inspection. A lot of great information there. You can download that as a free PDF. We, of course, have the installation manual available as a free download, too, for basic installation considerations. Again, so we've talked about this before. Here's the Find a Project page. There are a number of ways to drill down into this. You can see a little bit up on the left. You can sort these projects by coding. You can also sort these projects by application. So you can go in, you can sort by rehabilitation projects if that's specifically what you're looking for. You will see the couple of dozen projects that we have up there. You can also sort by detention, retention, DOT, and the like. These projects have all been part of our Project of the Year application process over the last 8-9 years. All excellent projects, and we continue to add to it. So please check back regularly. So again, just to touch on a couple of those that are in there. This is a rehabilitation of a small bridge near Wyoming. So this is, I think, a 120-inch diameter pipe. There are going to be several of these. They are long lengths, 60-foot lengths that have been slid underneath this railroad bridge. And then it will be backfilled to support. Now, the other unique aspect of what we can do with our materials is you see a CSP head wall to finish it all off, to make it real nice and finish looking. And of course, it will still carry that railway load. The next one we have up is another bridge replacement under the railroad. Similar application. This is a single track line down in Texas. So again, you have a multiple barrel installation slid through the struts in the timbers. You can see the lugs here that were used to slide them in and move the pipe around. Again, excellent project, excellent use of the materials. This next one is in Powhatan State Park, just east of State College, Pennsylvania. Unique project here. This is a 307-foot long curvilinear reline, right? So as Jerry was talking about, we used flowable fill reline for the encasement. The original tunnel was blasted out way back in 1880. And again, another really unique part of this is a bat conservation area. So you can't really tell from this photo, but there are some areas in here that allow for the bat population that lives here to move in and out. This next project is McCoby Creek in Upper Hanover Township. So this is an old stone arch. There are two of them in this picture. The second one is not shown, but you know you're reusing the arch, so you don't have to take it down and just reinforcing it. So another good application for the plate. These next couple are going to be pipe applications. This is in North Dakota. This is a culvert rehabilitation. We had some misaligned concrete pipe joints on Highway 27. So this was an aluminized type 2 pipe used spiral rib to get that hydraulic capacity, keep the hydraulics up. The next one is a similar project in Minnesota. You have a concrete box culvert that was in disrepair and another aluminized type 2 spiral rib solution. In particular, this was a 10-gauge, 60-inch diameter pipe. And you can see the equipment that was used to slide this puppy through the box. Finally, BNSF application in Devil's Lake, North Dakota. This particular pipe was galvanized. 5x1 profile, 8-gauge, 120-inch diameter. This picture in the top left shows you the concrete structure that was existing compared with the steel that was being slid in. This shows the struts that were used to keep everything tight, as Jerry had described. This is pretty much the final slide here. So lots of options, gang. You dream it, we can do it. We have lots of availability and resources out there from our members, from the association. You know, please feel free to reach out and ask questions. That is really what we're here for. Of course, follow us on the various social media channels to keep up to date on what we're doing, on projects, on information. You know, we have apps available for all the calculators that we've developed already: structural design, life cycle, cost, detention, retention, so on and so forth. And then, of course, for those that have been on these before, we will follow this up with a survey to you all to give us some feedback on how we're doing, how you found out about us, what we can do better. So once again, you know, thank you all for attending. We really appreciate everyone that's been here. Again, I know some of you have been here from the start. We appreciate the commitment. This has been a great experience for us as an industry and for me personally. So again, thanks again, everyone. Stay safe, be well. I don't really see any questions out there, but if you happen to think of any, you know where to find us, gang. Thanks again. Take care, everybody.